Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss about the lubricants and its properties. So, to be a good lubricant, what are the properties should have for a specific lubricant? So, the area of focus today on today's topic is viscosity, viscosity index, and flash and fire point, cloud and pour point, and oiliness of the lubricants. These are the properties. They are key properties and vital properties for the lubricants, and we are going to see in detail of this viscosity, viscosity index, flash and fire point, and the determination way, and how we are going to determine this flash and fire point and cloud and pour point of the lubricants, as well as the oiliness of the lubricants. First, a lubricant. First, the lubricant is a substance which reduces the friction. When two surfaces are moved, it causes a friction. So, it may generate heat, or it may transfer the energy, or the surface will be cooled. So, when two surfaces are rubbed or moved, it causes a friction. The uses of these lubricants reduces the friction between them to reduce the friction and wear between two moving surfaces. So this is the moving surface and this is the moving surface. When it was moved from one place to another, two surfaces are moved, it causes the friction. Here, friction increases. When the oil layer was used or a lubricant is used, which may be a mineral oil, which may be a powder or a lubricant powder, or which may be a semi-solid lubricants like grease, the uses of these lubricants between the two surfaces reduces the friction. So automatically what happens? The friction decreased means the life of the machinery will increase, or these two surfaces, suppose if it is made of metals, so when friction happens, heat generated. So the heat generated means these metals results in the changing its, deforming its shape. It may be expansion, it may be a contradiction. So due to the less friction or less generation of heat between the two surfaces, so this metal expansion contradiction won't happen. So this, because of this is nothing but the lubricant, which may be a mineral oil, solid lubricant, or semi-solid lubricant, or gaseous lubricant. Gaseous lubricant is nothing but the flow of air in between the two surfaces. So coming to the properties of the lubricants, the key properties of the lubricants are viscosity. So the viscosity explains the flow resistance of each lubricant which we are using, and the viscosity index, which is also called as VI of a lubricant, it measures the viscosity changes with respect to the temperature. So with respect to the temperature, it measures the changes of viscosity with respect to the temperature. So next thing is the flash point. This is the lowest temperature at which this lubricant converts or vaporizes, and it causes a fire when on introduction to a flame, on introduction to a small flame. So this all lubricant, so it evaporates and vaporizes and causes a flash point, that is called the flash point. And the fire point, the temperature at which it ignites for 5 seconds. So flash point means it will come as a spark and then it stops, whereas the fire point, the spark begins and it continues to burn for 5 seconds. That is called the fire point of a lubricant. And other relevant properties of the lubricants are oiliness, volatility, emulsification, and thermal stability. So the oiliness, this is the ability of a lubricant to form a protective film between the two surfaces. And volatility is the evaporation rate of a lubricant. And coming to the emulsification, The behavior in water oil mixture is called as emulsification. And coming to the thermal stability, it is the resistant to breakdown at a very high temperature. In general, the machinery will run at very high temperature, depends upon the application or the depends upon the manufacturing things in the industry. So these should tolerate the lubricants which we are using should tolerate the very high temperature, and it should not disintegrate or it should not break down even at high temperature. This is called the thermal stability of the lubricants. So again, in the key properties of the lubricants, we are going to see in detail these properties. One is viscosity, and another is viscosity index, and third one is cloud and fire point, and fourth one is cloud and pour point, and fifth one is oiliness. So these five we are going to see in detail what is viscosity and how we are going to use going to determine the viscosity, followed by viscosity index and flash and fire point, how we are going to determine the flash and fire point. The next thing is cloud and pour point. What is cloud and pour point and how we are going to determine which apparatus we are using. These things we are going to see in detail. So the key properties of lubricants, one of the key property is viscosity. So it is a measure of internal resistance of a liquid during its flow. Suppose if we see water, if we see water, the bonds are like this. So it is low viscous and the flow is uniform and very fast because of its less viscous nature. So viscosity is nothing but the internal resistance of a liquid to flow. Then coming to the oil, olive oil. So the olive oil have a this has a medium viscosity, and the thickness will be very less compared to the some castor oil or honey. So this olive oil will flow fast. This oil flow will flow faster than the honey but slower than the water because it is medium viscous. So the flow is like this. So this is olive oil. Next thing is honey. Because of its nature of its structure or arrangement of the compounds in the honey, this one is high viscous, so the flow is very slow. So viscosity is nothing but the internal resistance of a liquid to during its flow. So here the honey is having high viscous nature, so the flow is very less. So here we different milk, oil, egg yolk. So we can see the viscous here dot dot dot. See the flow is very slow, not like uniform like water. So here egg yolk. So this depends upon the viscosity of the liquid. The flow will be there. So it is expressed in this units is nothing but the centipoise. The viscosity of an oil is the time in seconds for a given quantity of oil to pass through a standard orifice under the specified conditions. How it is measured means it is measured because the flow of a oil or a lubricant is taken and it is measured in a specific standard orifice under specific conditions means like room temperature and at minimum heat or some temperature of heat or room temperature, and this is allowed to flow and the seconds is noted, and the given quantity of oil, suppose it is 25 ml means the 25 ml of oil is allowed to pass through the standard orifice at specific conditions, then the time is noted. So and this is expressed in terms of centipoise. So, what is the significance and what is the importance of measuring viscosity? So, if the viscosity of the lubricant oil is too high, the movement of the machine is restricted due to excessive friction. So, in between the two surfaces, suppose these are the gears. So, when here the oil is high viscous means very thick. So during this movement, it may cause the it may restrict the or it may slow down the machine process and due to excessive friction. If the viscosity of the lubricant is very low, means too low, what happens while movement, the liquid oil film cannot be maintained and excessive wear will take place. Very low means it may slide down and it won't be there in between the two moving surfaces. So what is the property to have a good lubricant means? The good lubricant should have a moderate viscosity. Means it's not too high, it's not too low. High means it slows down the machinery process and results in the formation of excessive friction between the two surfaces. If it is too low, the viscosity is too low, so the it cannot be maintained and excessive wear will take place between the two moving surfaces. So, for a good lubricant, it should have moderate viscosity. So, how we are going to determine? This is the viscosity of an oil is generally determined by redwood viscometer. It measures the viscosity of petroleum products in terms of redwood seconds. It calculates the time taken by oil to flow through a standard orifice and collect in a 50 ml flask. It is commonly used for determination of the viscosity of engine oils, lubricants, and other petroleum based fluids such as naphthalene oils and lubricants or grease or petroleum byproducts, crude oils. We can determine even for the diesel, petrol, kerosene. We can use this method for the determination of the viscosity of a specific liquid. So another method is which is called the Sebold viscometer. It determines the time to take for a fixed volume of oil to flow through a calibrated orifice at a specific temperature. So here the temperature will come into the screen. So in the Sebold viscometer, here it determines the time at a fixed volume at in a calibrated orifice at a specific temperature. The next key property is the viscosity index, which is also called as VI of a lubricant. So the viscosity of oil decreases with increase in temperature. So as we know, the viscosity index is the measure of the viscosity with respect to the temperature. So this is the viscosity index. So the viscosity of oil decreases with increase in temperature. So viscosity decreases with increase in temperature. So temperature increases means viscosity decreases. If the viscosity of oil decreases rapidly with increase in temperature, it has low viscosity index. Means viscosity decreases, then temperature increases means this is called low viscosity index. So low VI. If the viscosity of oil is slightly affected, so not decreased, means with slightly affected with the increase in temperature, it has high viscosity index. So the viscosity will slightly affected with increase in temperature, then it is called the high viscosity index. So for a good lubricant, it should have a high viscosity index. Means it should not decrease. It should have it may have the slight effect with increase in temperature, but the viscosity of the solution should not decrease with respect to the temperature. So the property should have for a good lubricant is it should have a high viscosity index. Generally, this VI is expressed in terms of the rate of change of oil of viscosity with respect to change in temperature. So, the value of VI is high when the oil is perfect. Even for the good lubricant we have seen. So, the value of VI means high if viscosity index of the oil is perfect, which means that the change in viscosity with respect to temperature is low or slightly affected. And for paraffin oils, the change is very low. And one of the paraffinic oils called Pennsylvanian oil is given VI of 100. And for naphthalenic oils, this change is very high. And one of the naphthenic oils called Gulf oil is given the VI of 0. The viscosity index is 0. So coming to the another key point called a flash point and 5 point. The flash point means it is the lowest temperature at which the lubricant vaporizes and gives a flash. So this Oil gives off enough vapor that ignite for a moment. Means it will give a spark for a moment when a small flame is introduced near to it. So this is called the flash point. So again, increase in the temperature increases the evaporation rate and increases the lubricant vaporization. So when a small flame is brought near to it, what happens? The flame continues to burn for a few seconds. Then it is called the fire point. So when a small flame is brought near to it, it ignites for a when it is ignited, it burns for a 5 seconds. Then it is called the fire point. Generally, the fire point is 5 to 40 degrees centigrade more than a flash point. So fire point is will be more around 5 to 40 degrees centigrade compared to the flash point. And this is called the apparatus, which is called Penske-Martin's apparatus. In this, we are going to find out the flash and fire point of any liquid. For a liquid fuels, we generally use this apparatus to determine the flash and fire points of any liquid fuels. So, what is the importance of finding this flash and fire point? Generally, these flash and fire points are useful in providing protection against fire hazard. So, the liquid fuels which are highly flammable, we should be careful because we should know at what temperature or what point it was giving the flash and what temperature it is going to fire. So, for this protection against the fire hazard during transport and even in the storage condition, we need to know the flash and fire point of a specific lubricant or a liquid fuel. Lubricating oils of paraffinic base possess generally high flash points than those of naphthenic base. Means paraffinic base oils will have more flash points than naphthenic base oils or lubricants. Hence, the determination of flash and fire point is helpful in identifying first the type of the lubricating oil. So, from the determination of flash and fire point, we can come to know whether it is a paraffinic base or a naphthenic base. So, this is also an indicator to find out which base this lubricating oil is came from. So a good lubricating oil should have a flash and fire points higher than the operating temperature of the machine. So suppose the temperature of the machine is very less, or the good lubricating oil should have a fire flash and fire point higher than the operating temperature. So suppose the machine is operating around 50 degrees centigrade and the flash and fire point is around 40 degrees centigrade, means it may cause the fire hazard. So it is not recommendable. And suppose if the machine temperature is 50 degrees centigrade and the flash and fire point should be above, means it may around 70 or 80 degrees centigrade. So unless it reaches the 70 degrees centigrade, it won't give fire or flash. So it is safe to use at lower temperature when machine is running at 50 degrees centigrade. This is the Penske-Martin's apparatus which we use for the determination of the flash and fire point of a lubricant. So the flash and fire point can be determined using the Penske-Martin's apparatus. This is the Penske-Martin apparatus. Here the cup will be there. This whole setup is made up of brass, and this is the stirrer. This is the temperature control, and this is the heating apparatus. So here the heating will happen. So this is the cup. This stirrer is attached to with the blades. So here we are going to fill the liquid or lubricant. So up to the mark, there will be an indication mark inside the cup. So up to the mark, we have to fill this lubricant. So once the lubricant was filled, it has to be closed in a proper way, and then the thermometer was introduced to know the temperature. Here we will, when it was switched on, so we have to adjust the desired temperature first for 50 degrees centigrade. So once 50 degrees centigrade reached, we have to introduce or we have to bring the fire near to it. If it gives a flash or a spark for a moment and then it stops, then it is called a flash point. And when it continues to burn for a few seconds after the flash point, then we have to take it as a fire point. So this small test has to be periodically bring in between for 5 degrees, for every 5 degrees centigrade temperature rise. We have to bring this flame to near to it and we have to check for the flash and 5 point temperature. Suppose if the flash point happened at 65 degrees centigrade, then this is the flash point of it. Means what happens? A just spark, it will burn and then it stops. Then again we have to see for 70 degrees centigrade, 75 degrees centigrade. We know the flash point will be greater of about 5 to 40 degrees centigrade than the fire point. So, fire point will have 5 to 40 degrees centigrade greater value than the flash point. So, for every 5 degrees, again we have to check. So, suppose 75 degrees, if we got the fire for it was burning for a 5 seconds, then the 75 degrees is the fire point of a specific liquid. Every time for every lubricant or a liquid fuel, the flash point will be a lower and the fire point will be higher. So the flash point is always will have lower temperature. So the fire point is greater than, simple thing, the fire point is greater than flash point, around 5 to 40 degrees centigrade for every liquid fuels and lubricants. So this application of test flame can be continued for 5 to 5 seconds, 5 degrees temperature, because the on heating the oil evaporates from the cup. Here this is filled with the lubricant. It evaporates. On heating it start evaporating. So where the vapors catches fire, that is called the flash point. Where these vapors still more continue to release even with the increase in temperature, so that vapor catches the fire and burns for a few seconds, then it is called the fire point. This whole thing will be done in a Penske Matters apparatus. So this is in detailed view of the Penske Matters apparatus. Here this is the lubricant, this is the thermometer, and this is the stirrer. These are the blades. So to have the uniform temperature all over the liquid, we will rotate from outside in like clockwise direction. So it gives, while heating, the temperature of the whole lubricant filled in the cup will be uniform. So once it reaches a desired temperature of, suppose the flash point of around 60 degrees centigrade, then it start evaporating. It vaporizes. So the vapors will come out from this burner. So here the pilot burner will be there, or a test flame we have to open every time for 5 degrees centigrade interval. See here the test flame was introduced in a interval times. So once it catch and it sparkle came, then that is called the flash point. And for the fire point, it continues to burn for a few seconds. Then it is called the fire point. So this is about the flash and fire point of the lubricants. So based on the determination of flash and fire points, we can know whether it is from the paraffinic base or naphthenic base. Even we can know the contaminants level in the liquid fuels as well as in the lubricants, because the contaminants are more involved or more present in the this lubricants. It won't give the flash and fire point at a specific desired temperature. So this is about the flash and fire point of a lubricants. The next thing is cloud and pour point. One of the key property of the lubricants is cloud and pour point. What is cloud point? So when oil is cooled slowly, the temperature at which the oil forms a cloudy appearance liquid, then it is called a cloud point. So we can see, so when an oil is cooled, so after heating, so when it is cooled, we can see the decrease in temperature at which the oil becomes cloudy in appearance is called the cloud point. In general, even coconut oil, if we see at the cooler conditions, at the cooler climates, means around 25 degrees centigrade, less than 25 degrees centigrade, it forms a cloudy appearance. Even ghee. So when it was cooled, it happens, it will form a cloudy appearance. Then it is called the cloud point of a specific liquid. So at what temperature it becomes cloudy means then it is the cloud point of a particular liquid. Then pour point. So the temperature at which the oil ceases to flow or pour is called as a pour point. Means, so again, even coconut oil, once the cloudy precipitate or cloudy appearance formed in the oil, once you heat it for a while, it start to flow. Then it is called the pour point. Same thing in the lubricants also. So it start to pour. When it flow or pour, then it is called the pour point of a specific liquid. So, what is the importance of this cloud and pour point? So, the most of the petroleum-based lubricating oils contain dissolved wax. It may be paraffin wax and asphaltic impurities will be present in the lubricants. So, this oil is cooled, these impurities present in the lubricant got solidification. Means it start to solidify. It results in the solidification of that a lubricant, which cause jamming of the mission. So the cloud and pour points indicate the suitability of the lubricants in cold condition. Suppose we are using these lubricants in cold conditions, so the operation temperature of the machinery is around less than 10 degrees centigrade or around 10 degrees centigrade. What happens? This lubricants which we are using in the cold condition will solidify because of the paraffin wax used in the from petroleum byproducts. These lubricants, from if it is a petroleum based, so the paraffin wax and asphaltic impurities present in these lubricants got solidified. So the solidification of these lubricants causes the jams in the machinery when it is operated, particularly at the low temperature. So the good lubricant should have this low cloud and pour points. So for usage in this condition, it should have very low cloud and pour points to use in this machinery at cold conditions. Then how we can determine this cloud and pour point of a lubricant? So an oil is taken in a flat. This is the apparatus. So the flat bottomed vessel, this oil is taken. So any lubricant which we are going to determine, or oil which, suppose it is a coconut oil or a lubricating oil or a grease, we have to take in a flat bottomed tube enclosed in an air jacket, and it is cooled down in a freezing mixture with ice and calcium chloride. Here, this is the ice and calcium chloride mixture. It was allowed to freeze. Here the thermometers has to be kept to maintain or to monitor the temperature. So the thermometers are introduced into the oil and freezing. This is ice and calcium chloride called freezing mixture. So thermometer has to be introduced in the freezing mixture as well as in the oil. So as the cooling takes place via here, what happens? The air jacket will be there. The cooling from the ice mixture, freezing mixture will transfer into the oil. So what happens? The temperature at which the cloudiness appears in the oil is noted as the cloud point, and further cooling is continued. The temperature at which the oil does not flow in the test tube for 5 seconds on tilting, means on moving in the horizontal position, is noted as the pour point. So this is about the cloud and pour point. The temperature has to be monitored. So due to the freezing mixture surrounded by a oil, it causes the temperature low down. So this is noted as a cloud and pour point. This is the apparatus used in the laboratory. This is the oil, and this is the air jacket, and this is the freezing mixture. This is the freezing mixture, which is called ice and calcium chloride, or ice and NaCl, which we can use anything. So the temperature at which the cloudiness appears is noted as the cloud point. Means whether it forms a cloudy precipitate, then it is called a cloud point, and the temperature at which the oil does not flow when we tilted in a horizontal position is noted as a pour point. The next key property is oiliness of a lubricant. It is one of the most important property of lubricants which possessed by generally by oils. So it is a property by which an oil remains adhered to the lubricating surface. Means because of its oily nature, the lubricating surface which we are using on the surfaces which will adhere to the lubricating surface. It is the property of the lubricant to stick on the surface under the conditions of high speed and heavy load. It is related to specific oil. It is related to specific of a oil. Lower the specific gravity, the higher is the oiliness of a lubricant. So these oils are generally either saturated means unsaturated fatty acids. Saturated unsaturated means it may contain double or triple bonds, or it may contain a single bond chain, fatty acid chain. So the vegetable or animal oils with high oiliness compared to mineral oils. This vegetable and mineral oil will have more oiliness compared to the mineral oil. Oiliness is an oil enhancement property provided through the use of chemical additives such as also known as anti-wear agents. So these are generally used in extreme pressure lubrication. So these type of liquids are used generally in extreme wear lubrication processes. So they are the key and relevant properties of the lubricants. So one understanding these properties and selecting the lubricants based on the application or the specific requirements of an application is crucial, because it is very important for ensuring optimal performance and long life of the machinery, because some machinery will run in cold conditions where some machinery will run in high conditions. So on the determination of the viscosity and viscosity index, which is respect to the temperature, the change in viscosity respect to the temperature, and again pour and flash and fire point, which is also like temperature dependent. So based on the requirement, we have to choose the lubricant accordingly. Based on the application, we have to choose the lubricant accordingly. So for this, we have to understand the properties of the lubricants in general. So we to know this flash and fire point and cloud and pour point, so it helps in the it helps in the selection of a specific lubricant according to our application. This is about the lubricants and its properties. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.